albeit a little bit late today. I have been discussing many things with my mother. I have a little bit of a little small trip coming up, and she's helping to watch the kitty cats. I can't leave them without a family member for this extremely short trip. It's just a couple of days, really. But I'm most thankful that my family is helping, and so this is why I'm late. I was explaining all of the babysitting duties to my mother. Hello, Faze. And before that, I went swimming, and the swimming, the showering, the all of that, plus the getting ready, plus the explaining of babysitter duties is why I have been running a little bit late. How is everybody doing? How are you? How are you doing, Faze? And any questions? Any questions, chat? Any questions? Shall I try to, you know what? Now there is a lot of light in my face because I clicked on some buttons on my laptop against which exists this phone. I wanted to share the live. Actually, if people could share the live, that would be amazing. I'm going to do a little bit of a reading before bed. Oh, good. The light is gone. I'm going to do a little bit of a reading before bed. We were basically almost done with the primordial black holes topic last night, but not quite done. And so we will go over that and finish that up, wrap that up before my trip. And by the way, I'm going to go live from the location where I'm going. It'll be a surprise, but I'm still going to go live when I'm traveling. So it's going to be a travel live. So stay tuned for that. So I will see you live even when I'm traveling. Even. How is everybody doing? Welcome all. Welcome one, welcome all. Thank you so much for being here. Welcome to the live. Thank you. I hope to see many of you today here, even though it's late. I hope to meet many new people and many of the old people as well. Robert, LSD. Hello. Hello, Robert. Hello, Faze. Hello, everybody. Welcome. Thank you for being here. Welcome indeed. And by the way, if you're seeing this as a video upload later on, thank you so much. I really appreciate your comments. Sorry for the lateness. Sorry that my live is a little late today. Hello, Faze. Hello, Robert. Hello, Asmir. Asmir Burka says, hi, girl. Hello. Hello, Asmir. Riley says, boy, this is so tough. Riley, what's up? What is tough? Vivian says, idol. Hi, idol. Hi, Vivian. Asmir says, you look so nice. Thank you. You look so nice. Aw, thank you so much. Hi, Hot Tamale. Hello. Hi, Ultimate Warrior. Hi, Mike D. Hi, Hot Tamale again. Hello, Jax Braun. Save 123. Hello. Your live is awesome, Sauce. That's what's tough. Oh, thank you. Hi, Mexi Ghost Hunter. Hello and God bless you. Thank you. Hello and God bless you. Thank you so much. Where are you from? I am from India originally. I'm in Boston. Good morning, says Hot Tamale. Good morning. Good morning, Asia. Good morning, Africa. Good morning, South America. Good morning, North America. Good morning, Europe. Good morning, Antarctica. Good evening as well to where it's evening. Good morning, good evening, good afternoon, good everything. Good day to all of you. Jax Brand says hello. and God bless. Are you married? Elijah, hello. Boston is cold. It's not too bad right now. Could you please like the live? Could you? Could you please like the live? Mexi Ghost Hunter says, live here in California. Elijah, free, I'm from America. You look like a baddie. I am kind of bad. It's true. Prism. Hello. Thank you, Mango Supreme. Mango Supreme. Mango Supreme. I liked. Thank you. Elijah says, what's your number? Give me a kiss first. Thank you for liking. Thank you for liking. Thank you. Juliet says, you're so pretty. Thank you, honey. Thank you, Juliet. Her number is 4. Why 4? I think my number is 1111. 11, 11. 2 11s. I'm trying to make this number. 11, 11. I like that number. 11, 11. This message is held for review. Hello, GWAR, GWAR. Quite an interesting message. Okay. Thank you so much for being here. I have to hide that one. That's pretty scary, GWAR. Thank you for liking the live. Thank you. Can we get 10 likes? Can we get 10 likes? Can we get 10 likes? Mexi Ghost Hunter. Your favorite pets. Pats? What is that? JJ640, hello. Mike D says hello from Modesto, California. Oh, I didn't realize, Mike D, you're from California. Thank you for 10 likes. Thank you. Oh my gosh. Thank you. Thank you for 10 likes. I've been drinking some olive juices. Thank you for 11 likes. Thank you. Can we get 20 likes? Mango Supreme says it's really subprime. Oh, I see. Mango subprime. Hello. Prithvi says Indian origin ? Yes, Prithvi. Aren't we all Indian origin? Plasmoid Eater says, can you say hi to my friend Hugh Jazz for him, please? Hello, Hugh. Hello. Lily says, so pretty. Lily, you're pretty. No, you. Thank you for liking. Can we get 20 likes? Elijah says, charisma. Thank you, Elijah. JJ640 says 1111. Yes, indeed. I love it. Mike D says 1111. Thank you. Lily says you're so kind. Thank you. You are as well. Mango Supreme says, what is it? What is what? That's a spiritual number. I see it a lot throughout the day. Me too. I'm an 1111 girly. An 1111. I love your expressions. Thank you, Lily. Do you know the difference between a chickpea and a lentil? I just ate chickpeas. How did you know? My friend? I just ate chickpeas. I just did. And you tell me what the difference is. Elijah says, you got for real, Chris. Your favorite pets? What does that mean? What's a pets? Do you mean animals? Pets? My favorite animal is a kitty cat. Thank you for liking. Can we get 20 likes? Colin says, can we get a 360N? What? 360 as in all the degrees? Elijah says, how old is he? Jody Watts says 999. Lily says, I love your lives. Thank you, Lily. You're the best. I think I just said hi to Hugh Jazz. Hugh Jazz, your friend Plasmoid really wants me to say hi to you. Hi, Hugh. Hello, Hugh. Colin. Likes will skyrocket for a 360. 360 of what? How old is you? Can we do a 20? Thank you. Can we get 20 likes? Thank you. Hi, Jody. Hi, Thanos. Parvin. Thank you, Parvin, for the emojis. Love it. Thank you. Can we get 20 likes? Mexi says, you have a voice for a cartoon character. Which one? Which one? Dexter's sister, Didi? What's your number? I'm trying to get that. How old? Duncanville. Don't know what that is. Janice T says, please, I'm dying of hunger. Oh no. I forgot to tell you it's my birthday. Happy birthday. Happy birthday to you. Colton says, does it clap? Clap what? Does what clap? Like that? Trust the process. I love it. Cousin's birthday. Caden, can you turn the 7-year-old? He didn't want to say hi. Oh no. Hi, Caden. Steve, of course, remember you. Of course I remember you. How are you, Steve? Elijah, thank you. Happy birthday to my cousin. 360 of you. Oh. 360 of me? There. I'm on a bar stool, so. Lily says, I love the way you thank everyone and how you respond to everyone so you don't leave anyone out. It is kind of you to do. Thank you. I always do that. I try to. Milak Yasharahala says, do you have a beautiful small face? Well, I think small is relative. XX says, where's the black hole talk? Now that you mention it, XX, we will definitely do a black holes. Can we get 20 likes? Diana Sanchez says, hello. Lily says, it's also my birthday. Goodness, happy birthday, Lily. Happy birthday to you. Happy birthday to you. Happy birthday. Happy birthday to you. Steve says, I'm good, mate. How are you? What's the delay on this stream? I don't know. Is there a delay? Thank you. Thank you for the hearts. Thank you so much. Can we get 20 likes? Can we? So kind, so pure. Thank you. Thank you, honey. And my cousin's birthday. Can you say happy birthday? Yes. Happy birthday to Elijah's cousin. What's the delay on the stream? 2 years before a response. Maybe it's me. I have to read through all the comments, and I'm giving a shout out to everybody and reading all their names and all their comments. So just have to wait your turn, XX. I love the name Trust the Process, by the way. Sometimes I go up and say hi again just to make sure that I got everybody. Thank you for 15 likes. Can we get 20 likes? Steve, good to see you. Love your toy pups. Donna says, what are we going to be talking about here? Well, soon we're going to talk about black holes. But before that, I'm just hanging out and saying hi to everybody. Just saying hi. Just saying hi to everybody for right now. But soon we're going to do black holes. Thank you for 16 likes. Can we get 20 likes? Can we? Love our toy pups. Hello, darling. How are you? I low-key love watching these. Your voice is so sweet. Thank you. Thank you. Here's a brief history. Can you shut off your... Shut what? Here's the book, Brief History of Time. And we have been talking about the black holes. This is by Stephen Hawking. And in fact, he worked on black holes for his PhD thesis. Now, this whole week, we've been covering something or other about black holes, generally referencing this book. And there's just a little bit of black hole stuff left in the chapter that we were on. And we were just talking about like primordial black holes last night. And thank you. Can we get 20 likes? Hello, Slap, Chop, Nuds. So, we were talking about primordial black holes. And we will continue. So, this is from the chapter, Black Holes Ain't So Black. 3 more likes. Yes. Where do we give you a like? You just double tap the screen. Double tap. Tap. You just double tap. 3 more likes. I have to pin Lily. Lily, you've been most helpful here. Thank you. So we talked about black holes. Now, of course, Stephen Hawking worked on black holes for his thesis. Steven Spears is here, as I mentioned. Just as I mentioned Stephen Hawking, we have Steven Spears here. Britney Spears related person. I'm double tapping and nothing's happening. Oh gosh. Oh, thank you, honey. So, after talking about the black holes for a while, we were looking at primordial black holes. And in fact, remember how, if you've been in the lives, by the way, if you are interested in the black hole stories and missed the lives in this week, earlier in the week, then you can go and check the previous lives out on my channel under the live tab. So you can like listen to all of the topics, all of the content that we discussed. 2 more. If you swipe down from top of phone. Oh, don't tell them to swipe. I don't think that's gonna be very helpful. I think double tap will like the live. So Elijah, you know, you're being quite rude, but you first had me say happy birthday to your whole family. So I'm not sure what you want at this point. Are you ill? Happy birthday and safe recovery. I think my mods have fallen asleep by now, or they would be quite mean to you. Just saying. They have jobs in real life, and they bully the bullies. So they're not as nice as me. Not as nice. I'm the nice one. Good thing it's just me today. Double tap works, but I mean when you swipe under your name and like button, you can like there too. 2 more! Yes! So we found how bigger the black hole, lower its temperature. And then we were discussing primordial black holes. So let me continue. So remember he was talking about finding some of these black holes, like the primordial ones, and how there might be like gamma rays coming from them, and if we have any hope of finding one that's sort of in our own solar system, let's say, what are the chances and things like that. So that's sort of the point at which we left off, and we can continue from that point here. No Doro or Reese. No, I think I missed them. It's probably too late / early for Reese, and then it's probably too late for Doro. I might have missed them. So, of course, if a black hole as close as Pluto, so let's say if there was a black hole at the same distance as Pluto, this is the case that we're looking at right now. From the book Brief History of Time by Stephen Hawking, from the chapter Black Holes Ain't So Black. What is a chemistry? So if a black hole as close as Pluto were to reach the end of its life and blow up, it would be easy to detect the final burst of emission. But if the black hole has been emitting for the last 10 or 20,000 million years, so a million has 6 zeros, 1,000 will be 3 more, so that's really a billion. So if it was for the last 10 or 20,000 million years, or really a billion years, the chance of it reaching the end of its life within the next few years, rather than several million years in the past or future, is really rather small. So part of the conversation or the thinking here is maybe we just are not catching the thing at the time when it would be bursting up into flames or reaching the end of its life or something like that. So part of it is also the timing, and we as human beings on Earth may or may not overlap in time with certain sort of astronomical or cosmological events. We are only here for, pretty recently compared to the age of the universe, even the age of the Earth, right? 4 billion years, 13.6 billion years. Those are much longer than while we have been around. So to expect something kind of rare to happen overlapping with our lifetimes and our civilization on Earth is a little bit maybe far-fetched. So that's sort of what's going on here. And the thing is, with cosmology, astronomy, astrophysics, like sometimes it's really the giga-year that matters, not so much the century or the millennium or even thousands of years, but more, or even a million years is kind of short compared to hundreds or thousands of million years. So for example, the sun, we consider the sun to be pretty permanent. We get all our life, energy, power, obviously all that heat, everything we need to really be alive from the sun. The sun promotes photosynthesis. Plants are alive. Plants are very helpful for a number of reasons, um, things like that. But the sun is actually quite young compared to, say, the galaxy or the universe. The sun has only gone around our galactic center 20 times, just around 20 times. So in the galactic age, the sun is like a 20-year-old. So the sun is a very young star. By the time the sun becomes a giant and is closer to its life cycle, end of its life cycle, we will have merged with our neighboring galaxy, Andromeda. And our galaxy's shape will be different. We will be part of a bigger elliptical shaped galaxy by then. Who knows where we will be as human beings, but those are the sorts of timelines to keep in mind when you're considering things in cosmology, which is the study of the universe, and astronomy, which is the study of the heavenly bodies. Okay, so with that in mind, we will continue with thinking about these primordial black holes. Because if there was one as close as Pluto, what are the chances that we really see it doing something like its final burst of emission being close to the end of its life, really? So, but if the black hole has been emitting for the last 10 or 20,000 million years, which is really a billion years, the chance of it reaching the end of its life within the next few years rather than several million years in the past or future is really rather small. So in order to have a reasonable chance of seeing an explosion before your research grant ran out, you would have to find a way to detect any explosions within a distance of about 1 light year. And 1 light year is not even, I guess, that big. Again, I'll give you some examples. The galaxy that we are in is 100,000 light years across. So it takes light 100,000 years to go from one end to the other. So 1 light year is just whatever distance that light travels in a year. And in the scale of the universe, in the scale of the galaxies, again, not that long. But in our scale, human being scales are very different than astronomical or cosmological scales. We think of a meter as a pretty good scale. So a meter, several meters, miles, those aren't really what we consider anymore to be appropriate when we consider things happening in astronomy or cosmology. So 1 light year. In fact, bursts of gamma rays from space have been detected by satellites originally constructed to look for violations of the Test Ban Treaty. So this is gamma ray bursts just in general. In general, we see gamma ray bursts, like we've talked about gamma ray bursts in the past. It was something I studied myself. So we have a certain number of gamma ray bursts that we see. We monitor them. We have a roster, basically, of gamma ray bursts that we collect upon. As they happen, we say, okay, yeah, this is it, this is this, this is it. Like, it's a number of transient events that emit gamma rays. Once detected, we make a note of that. This happens throughout the year. And they are generally all coming from other... They're generally... yeah, they're generally all extragalactic. Generally, we don't see gamma ray sources, gamma ray bursts in our own galaxy. There have been some radio bursts, though. Can I ask, is there a time scale, like days for a light year? Yeah, so I mean, the sunlight comes to us in 8 minutes. So the distance between us and the sun is 8 light minutes. So the light year, or a light minute, or a light hour is a length. It's just the length of the length traveled by light in a certain amount of time. Because the speed of light is a very large number, and the distance between the sun and the earth is pretty large as well, compared to the distances that we're used to. So another way of putting the distance between us and the sun, we call it 1 astronomical unit. We actually take that distance between us and the sun and call it 1 astronomical unit. Another way, there's different ways of saying the same thing. Another way is to say that the distance between us and the sun is 8 light minutes. So the distance that light travels in 8 minutes is the distance between us and the sun. So you actually can think of things as light hours, light minutes, light days, light years. Generally, when you're considering galactic scales, it's going to be light years probably, but you know, it can be closer, like the sun is closer to us than other things. So it's more like 8 light minutes of this for the sun and us. So, but I think is there a time scale? Oh, maybe you're asking something else. Is there a time? So because we know that the speed of light is 3 times 10 to the 8 meters per second, it's kind of like it's a constant of nature, the speed of light in vacuum, and it's a kind of big number. So instead of thinking of things as, it's basically us not wanting to deal with that big number all the time and do the math, but say that, what is the length that light travels in a certain time? It's basically saying the same thing kind of differently. So light year, in spite of its the word year is really a distance, is really a scale for length, is really a unit of length. Okay, so light year is a length. A light minute is a length. A light hour is a length. A light day is a length. Because we want to deal with, it all comes from a convenience. We're dealing with very large distances, and so we want to have some way of saying that without getting into very large numbers in like meters and miles and stuff. So the first gamma rays were actually discovered by the military during the Cold War. People thought that, I believe that the Vela satellites were involved. So Stephen, you might have heard of these Vela satellites, and we might have talked about it too on the channel here, because I've talked about gamma ray bursts before for sure. So at first people thought that these were like a violation of the treaty. I think, oh, I see. Yeah. The metric, the SI unit, the scientific unit is meters per second. So it's a lot of meters per second. It's 3 times 10 to the 8 meters per second in the scientific units. So, but yeah, miles per second. I don't know miles per second very well. So there you go. So at first, these military satellites, they thought that this is some violation of the treaty during the Cold War, this test ban treaty. But actually, these were gamma ray burst sources. Yeah, so you've heard of the Vela satellites? Was that, you might have been around for that. You might even have been around for that. The military thought that the Soviets or somebody were detonating nuclear weapons in space. Right, so there's this test ban treaty. I'm guessing the test would be for nuclear weapons. It was, I want to say 1960s maybe, or 1970s. It could, it could be the 60s or the 70s. I forget the exact year, but it's maybe he'll mention it in the book, but I forget the exact year. But it was during the Cold War, and the Vela satellites saw the first um, the Vela. So yeah, look up gamma ray bursts, Vela satellites, VELA. They saw that and they thought, oh my gosh, is this like basically signature of the tests happening for nuclear weapons in the Cold War? And so it was actually a military discovery that led to us finding gamma ray bursts. And then these are transient events in the sky that are the most luminous events in the sky for as long as they're going off. Typical gamma ray burst length is only a few seconds, couple seconds. There are some gamma ray bursts are longer, some are shorter. So there's long gamma ray bursts, short gamma ray bursts. But turns out that they're basically all extragalactic. They don't happen really in our galaxy. Also, they're isotropic. They're very far away. They're gigaparsecs away, generally, and isotropic. There's no particular direction really that we get more from. But anyway, the same gamma ray bursts are what Stephen Hawking is talking about here in connection with primordial black holes and kind of hypothesizing whether we would see any from the primordial black holes, okay? But before we saw gamma ray bursts just period at all, because of the military, they weren't really something that we thought about too much. Because, yes, that's what I thought, 1967, that sounds about right. Like 60s and 70s sound about right for the gamma ray burst discovery by the military. So gamma rays are very energetic photons. They're very short wavelength and high frequency, high energy photons. So unless you saw some, you have no reason to think that such a thing has to exist, really. So, and this book was written 1988 for the first time. So I guess when the book was being written, they were known. Because, yeah, as soon as they were discovered, you know, even though they thought it might be like the Russians doing something, turns out that they're obviously a very natural event. And also, if you remember my other discussions on gamma ray bursts or GRBs, they are nature's most exotic particle accelerators, basically. Like, the theories about them is that certain particles, both leptons as well as hadrons, are, or basically like baryons, protons, things like protons, are maybe accelerated greatly in an environment like a gamma ray burst. And so certain processes are hypothesized for an environment like that, which is good for us to kind of probe and stuff like that if we did see gamma ray bursts. So yeah, 1967 they were discovered. Steven Spears was 2. There you go, Steven. Old enough to understand gamma ray bursts. But yeah, that's cool. Okay, thank you so much for the likes. Can we get 2 more likes so that we get 20 likes, please? That would be amazing. But yeah, so in fact, bursts of gamma rays from space have been detected by satellites originally constructed to look for violations of the Test Ban Treaty. So because he's writing this in 1988, it's been some time since the initial discovery of gamma ray bursts, but it took some years to really understand them and for people to really theorize about gamma ray bursts and understand what could be the processes going on inside the gamma ray bursts. And even now there are certain things that are kind of like unknown. So I could see how when he's writing this book, especially for the first time in 1988, not everything would have been known by then. So these seem to occur about 16 times a month and to be roughly uniformly distributed in direction across the sky. So this they already knew. The fact you get roughly 16 of these a month and roughly uniformly distributed in the sky, meaning that there's no particular direction they seem to be coming from, meaning isotropic distribution. They're coming from very far, far away, and it's sort of that we're randomly seeing, they happen far away. We randomly see some type of thing. It's not a certain particular source, say in the galaxy, that's producing these. So this indicates that they come from outside the solar system, since otherwise we would expect them to be concentrated toward the plane of the orbits of the planets. The uniform distribution also indicates that the sources are either fairly near to us in our galaxy or right outside it at cosmological distances, because otherwise, again, they would be concentrated toward the plane of the galaxy. In the latter case, the energy required to account for the bursts would be far too high to have been produced by tiny black holes. But if the sources were close in galactic terms, it might be possible that they were exploding black holes. So in general, we know that gamma ray bursts actually occur quite far away. Like most gamma ray bursts that we have in the catalog of gamma ray bursts, there's a gamma ray burst monitor. There's a catalog of gamma ray bursts that you can find from every year. They occur quite far away. Stephen Hawking is interested in this book in the ones that may or may not be potentially maybe coming from primordial black holes, if such a thing were to exist, and if such a thing were to happen to give off gamma ray burst like during our lifetime, etc. But in general, we know that gamma ray bursts, most of them happen very, very far. Okay, so again, so in the latter case, the energy required to account for the bursts would be far too high to have been produced by tiny black holes. So most likely they're from other reasons like supernovae. Actually, we know that long gamma ray bursts are, at this point, we know more about gamma ray bursts generally. The long ones, long gamma ray bursts, which are longer than the typical 2 seconds long, could be a lot longer than 2 seconds. Those gamma ray bursts are associated with hypernovae. These are just really, really large supernovae. So like stars dying. And the short gamma ray bursts, which is like less than 2 seconds long, those are associated with neutron star merger, or neutron star black hole merger, or black hole merger. Basically, they're associated with cataclysmic mergers of compact objects like neutron star, or black holes, or neutron star black hole. And by the way, we have confirmed these now with LIGO by way of gravitational waves. So because we saw gravitational waves coming from such a merger, and we saw the gamma rays, we have multi-messenger astronomy type of way of confirming short gamma ray bursts, which was, by the way, a delight. Just made me very happy because I like gamma ray bursts, and the short ones were not really confirmed until recently. So, and by recent, I mean several years ago. So I would, Stephen Hawking says, in the latter case, the energy required to account for the bursts would be far too high to have been produced by tiny black holes, but if the sources were close in galactic terms, it might be possible that they were exploding black holes. I would very much like this to be the case, but I have to recognize that there are other possible explanations for the gamma ray bursts, such as colliding neutron stars. So when he wrote this book, they did not have confirmation that colliding neutron stars could produce short gamma ray bursts. But now we do. So I am so sorry for Stephen Hawking. He probably loved primordial black holes, so it would have been great to find them for him. But gamma ray bursts do have other explanations. And in fact, the ones I mentioned about the long gamma ray bursts being pretty much hypernovae, and the short gamma ray bursts being pretty much colliding neutron stars or black holes, is pretty much, that's what they are, basically, as far as we know. Hi, John Foster. Hello, Slap Chop Nuts. I've seen the original Star Trek. I already know this, of course. Okay, Slap Chop. Hi, Phase. Are they dangerous? Yes. They're very dangerous, but they're generally not in our own galaxy, so you're safe in the Milky Way. Yeah. Hi, John Foster. Hi, Steven. Hi, Faze. Hi, everybody. So, new observations the next few years, particularly by gravitational wave detectors like LIGO, should enable us to discover the origin of the gamma ray bursts. So, again, he's talking about the short gamma ray bursts. Those are confirmed to be associated with colliding neutron stars or colliding neutron star black hole binary or black hole binary. And the long gamma ray bursts are confirmed with hypernovae or very large supernovae. When he wrote this book, all of this was not confirmed yet, but now it is. Even if the search for primordial black holes proves negative, as it seems it may, it will still give us important information about the very early stages of the universe. If the early universe had been chaotic or irregular, or if the pressure of matter had been low, one would have expected it to produce many more primordial black holes than the limit already set by our observations of the gamma ray background. Only if the early universe was very smooth and uniform with a high pressure can one explain the absence of observable numbers of primordial black holes. So only if the early universe was very smooth and uniform. Hi, Suji Mama. Sachi is on a very high cabinet. Suji! So if it had a lot of high pressure, very smooth and uniform, then maybe not. The idea of radiation from black holes was the first example of a prediction that depended in an essential way on both the great theories of this century, general relativity and quantum mechanics. So he basically had to use both of those theories that kind of conflict with each other in certain senses, in certain cases. But Stephen Hawking had to be a good student of both general relativity and quantum mechanics in order to talk about, hi Mama, in order to talk about and in order to discover radiation from black holes and the black body radiation from black holes that he worked on, called Hawking radiation. It aroused a lot of opposition initially because it upset the existing viewpoint, how can a black hole emit anything? When I first announced the results of my calculations at a conference at the Rutherford Appleton Laboratories near Oxford, I was greeted with general incredulity. So people were incredulous that, this guy is talking about black holes emitting something. But of course, if you listen closely, he's talking about those quantum fluctuations near a black hole and the particle antiparticle business, which, once you come to think of it, it's actually nothing more bizarre than what quantum mechanics very much offers in the form of its sort of probabilistic nature and fluctuating sort of fluctuations, probability. These are all very much within the realm of quantum mechanics. These are all allowed in quantum mechanics. So, and if you're considering, some particles being emitted and getting some low temperature associated with especially the bigger black holes, then it's not so ridiculous at the end. At the end of my talk, the chairman of the session, John G. Taylor from King's College London, claimed it was all nonsense. He even wrote a paper to that effect. However, in the end, most people, including John Taylor, have come to the conclusion that black holes must radiate like hot bodies if our other ideas about general relativity and quantum mechanics are correct. Thus, even though we have not yet managed to find a primordial black hole, there is fairly general agreement that if we did, it would have to be emitting a lot of gamma rays and X-rays. So if you see a source of a lot of gamma rays and X-rays, it very well could be a primordial black hole. So pay attention if you come across that. It's either some illegal nuclear weapon testing or a primordial black hole. I guess both are quite interesting to chance upon. The existence of radiation from black holes seems to imply that gravitational collapse is not as final and irreversible as we once thought. If an astronaut falls into a black hole, its mass will increase, and we mean the black hole's mass. God bless the astronaut. They will cease to survive, I suppose. If an astronaut falls into a black hole, its mass will increase, but eventually the energy equivalent of that extra mass will be returned to the universe in the form of radiation. Thus, in a sense, the astronaut will be recycled. Nothing is really for free. Even the black hole has to pay a price. It's like lunch for the black hole, this astronaut, but then the black hole has to pay a bill as well. There are no free lunches in this universe, even for black holes, apparently, according to Stephen Hawking. What's up, Slapchop? Ask your question. It would be a poor sort of immortality, however, because any personal concept of time for the astronaut would almost certainly come to an end as he was torn apart inside the black hole. So now the other thing is that even though the black hole may pay a bill for his lunch, for its lunch, which is this astronaut, it's not like the astronaut really gets to have an enjoyable time anymore. In fact, the concept of time is done for the astronaut. So Stephen Hawking said, the Big Bang is a singularity which started off time, and black holes are a singularity that end time with their very high gravitational field. So time just kind of stops. Regardless of what you saw in Interstellar, time is no longer a thing in the black hole once you're in it. So even the types of particles that were eventually emitted by the black hole would in general be different from those that made up the astronaut. So it's not even that you're getting the astronaut back. It's going to be some other thing. So even the types of particles that were eventually emitted by the black hole would in general be different from those that made up the astronaut. The only feature of the astronaut that would survive would be his mass or energy. The energy bill is paid always. There are really no free lunches when it comes to energy. The approximations I use to derive the emission from black holes should work well when the black hole has a mass greater than a fraction of a gram. However, they will break down at the end of the black hole's life when its mass gets very small. The most likely outcome seems to be that the black hole will just disappear, at least from our region of the universe, taking with it the astronaut and any singularity there might be inside it. If indeed there is one, this was the first indication that quantum mechanics might remove the singularities that were predicted by general relativity. So even though the classical physicists, the people who, Einstein and others who, they like general relativity, but they don't really like quantum. But, lo and behold, maybe quantum mechanics removes those singularities or the weird parts of general relativity, So this was the first indication that quantum mechanics might remove the singularities that were predicted by general relativity. However, the methods that I and other people were using in 1974 were not able to answer questions such as whether singularities would occur in quantum gravity. From 1975 onward, I therefore started to develop a more powerful approach to quantum gravity based on Richard Feynman's idea of a sum over histories. The answers that this approach suggests for the origin and fate of the universe and its contents, such as astronauts, will be described in the next 2 chapters. So next he will talk about that. We shall see that although the uncertainty principle places limitations on the accuracy of all our predictions, it may at the same time remove the fundamental unpredictability that occurs at a space-time singularity. Wow. We shall see that although the uncertainty principle places limitations on the accuracy of all our predictions, it may at the same time remove the fundamental unpredictability that occurs at a space-time singularity, which is basically what a black hole is, or the Big Bang. Thank you. Thank you, thank you, thank you. Thank you for 20 likes. I see 20. I saw the astronauts land last weekend from the ISS. Oh, good. Does the black hole have a credit score? I guess if it did, it's a very poor one. It keeps eating things and not paying its bill in a, I guess, societally acceptable way. The utilization of mRNA vaccines in the context of infectious disease has no precedent. Hello, Tarot Destroyer. mRNA vaccines, yeah, love it. Time is meaningless. No. Time is meaningful outside of a black hole. Time is meaningless once you're inside of a black hole. Then your time is kind of done. The Bears TV says hello. Hello, Bears. Hello, Tarot Destroyer. Thank you for the likes. Good morning, Ram Candy. Do you think a black hole can be created on Earth? I think these primordial black holes was something that people kind of thought about, or some small black holes is something that people did worry about. Yes, they worried about it, but I don't think it's that bad. I don't think we have to worry about them too much. If it was, Earth would cease to be, in my opinion. Thank you, Ram Candy. Hello, Andrew. Andrew says, Miss Intelligent, ¿cómo estás? ¿Cómo estás, Andrew? How are you? ¿Qué pasa? Thank you for being here, everybody. So this was A Brief History of Time by Stephen Hawking. We talked about black holes ain't so black. The next chapter You want the red sweater? When you're done with that red sweater, let me get it. I like it. Oh my God. Are you saying I wear this red sweater too much? It is a good sweater. I like it. It has some holes in it though by this time, because the kitty cats like to scratch it. Are you saying I like I wear it? You wear it? I wear it too much? Nah, I like the style. Oh, good. So the next chapter in the book is called The Origin and Fate of the Universe. We will definitely talk about this. Steven says, I can never wear a sweater. Andrew says, it's a nice sweater, I'll wear it myself. Thank you. So we will talk about the origin and fate of the universe next. And then, that's quite a long chapter. Then we'll talk about, let me just see the contents. So we did black holes ain't so black. Next, we will talk about origin and fate of the universe, the era of time, chapter 9, wormholes and time travel. Steven, didn't you ask about wormholes? We're going to talk about that in chapter 10. We can also talk about wormholes more generally, but I think we're going to listen to what Stephen Hawking has to say. And I will get the book by Kip Thorne. I know he has worked on wormholes as well. Hi, friends. Franz Lothman says, hi, beautiful girl. Thank you. Hello. But yeah, so Stephen, I believe it was Kip Thorne who gave us sort of a wormhole that might work. Like a wormhole that might actually kind of work. And remember how when we were talking about this book, we were reading one of the chapters in this book, Stephen Hawking mentioned some bet he had with Kip Thorne and them. And I think Kip Thorne went to, or he worked at Caltech. So I think basically Stephen Hawking was saying that wormholes are like far-fetched or not good or something can't happen. And then Kip Thorne said, or Kip Thorne found a way for them to be possible or something. I think it was like two charged, something with like charged plates and whatnot. I've seen Tremors. I haven't seen Tremors. So I love the movie Tremors. Really? Steven, tell us about Steven and Slap Chop. Tell us about the movie Tremors. What happens in Tremors? So we'll see what Stephen Hawking says about wormholes and time travel. And then I have to get Kip Thorne's book because he also worked on wormholes. The next part is chapter 11 is the unification of physics. Good. And then there's just the conclusion. So we have a few more things to get through. This has been most interesting. Movie Tremors. Tell me about the movie Tremors. Thank you for joining for this late night live. Sorry I missed some people. Probably went to bed. Probably in bed by now. Are you cold? Yeah, it's kind of cold here. Why? It is kind of cold in Boston. Is it not cold where you are? John Foster, aren't you in Michigan? Or something? Isn't Michigan cold too? Oh, the sweater? Yeah. I do have the sweater on. Oh, Arizona. Oh, Arizona is very warm. For some reason, I thought you're in Michigan. I think I've got maybe someone else from Michigan. Steven said, I just cannot stand sweaters personally. You don't like sweaters? Why? I mean, I wear them when I'm cold. Kevin Bacon stars in it. He is living in this tiny, isolated town in the desert when 4 or 5 foot long worms attack, killing people. Is that the wormhole? You have that jacket on. I was raised in Michigan. Ah, okay. So you know the cold. Yeah, it's cold here. I mean, cold as in not as cold as the winter, but it's spring, so it's still a little chilly. Outside is really cold. Like I walked back from the gym, like from the car, and oh, it was cold. I wore a light jacket. And boy, it was cold. It's cold outside. Good memory though. Michigan? Yes, I remember. I thought it was Michigan. Yeah, it's like 35 degrees. Yeah. Mm-hmm. But I also went swimming. And so when I go swimming, and if I swim a lot, then I get cold in the hours following. Which reminds me, I forgot my protein shake again. I'm supposed to drink protein, but I never do. I'm so sorry, body protein police. I'm a native Virginian, lived in Florida for 2 years though. Okay, yeah, that's what I thought. I know you're in Virginia, Steven. Hi, Suji Mama. Hi. Hi. Hi, Mama. I'm a native Virginian. Suji Mama is such a good mama. Do you eat food with iron? I think so. When it's 50, I feel cold. That water doesn't help. The water, but I'm thirsty. Do you eat food with iron? I think so, yeah. I do. Why? Does that help? Does that have protein? Is that protein? What are you saying? Probably with a fork or spoon. Protein? Yeah. Ooh. I ate chickpeas. I ate chickpeas today. Does that have iron? Hi. Hey, Sachi. Just want Sachi to climb on me. Sachi, come back. Oh gosh, the laptop is so bright. Putting all the bright energy in my face. Oh gosh. Baji's over here. I lived in the suburbs of Washington, D.C. most of my life. Up there, most residents were either military or government. Yeah. Transient residents. Oh my gosh, yeah. DC, I almost moved to DC. I worked in the government as well. So, oh my god. DC is obviously has so much government and defense contractors and things. So, those people do move around probably, and as you said, very transient. In the Boston area too, it's a lot of transients because of like the schools and students coming in and out of the city. But I feel like DC is even more because of the jobs. I'm not sure. I know green vegetables might have greens and spinach have iron. Yes, that's correct. When I was sick, my friends figured out that I should have a lot of iron, and they were cooking like dal, like lentils with spinach for that reason. But in general, I think I don't get enough protein, and so I'm like supposed to eat more protein because I don't eat a lot of meat usually. I basically don't eat meat unless I go out and or someone else is cooking. Like I don't buy it, and I don't bring it home to cook it myself. So, because I don't cook a lot. So meat is one of those things which I'm borderline vegetarian. Yes, I'm an opportunistic meat eater. So I basically at home by myself, or even with like my mom visiting, me and my mom are both like maximum what we might like if like left to ourselves, we don't cook meat. We don't cook meat. We don't cook fish. We don't cook anything non-veg, really, other than like eggs. Like I love eggs, boiled eggs, or like breakfast eggs. So the maximum animal product that I eat at home is milk, and so like coffee. I drink coffee with milk powder or whole milk. So mostly water, but some whole milk and or milk powder. So that's an animal product. And then I eat eggs. I love eggs because they're very easy to make. Like basically we don't like cooking, period, and we especially don't like cooking meat because with meat you really have to make sure that it's cooked. Like chicken and everything, right? You have to make sure it's cooked. So, and I don't really like fish, to be honest, unless someone is making it and they're like very good at it. So if someone else wants to make anything, be my guest. But me and my mom, we don't really cook meat and stuff. My dad cooks meat. But so I probably eat whatever he makes like a couple times a year. And it's whenever I would eat out, or if a friend of mine cooks it or something. I eat boiled eggs, whole milk. I can't drink it anymore. I like oat milk. Yeah, I've had oat milk as well. I drink lactose-free whole milk. It's a full it's a food, right? Yeah, I'm lactose intolerant as well, so I get the lactose free whole milk. Brett, hello Brett. Brett says, were you asked to do or say something immoral? Immoral? What do you mean immoral? By who? Oh, that's why you drink coffee black. No, I drink coffee with the either whole milk or and water. Like I put in some whole milk and then I mix the rest with water, or put water into the rest of the cup, or I put milk powder. So I don't drink it black. I drink it with milk. Either milk. Yeah. I mix it. I put the coffee powder in, because I use Nestle instant coffee. Maybe One of these days, I'll show you guys how I make my coffee. I'll do a live with my coffee. So I put in the retract my question. What question? Hi, Varun. Varun says Baji's looking really sweet. Aw, thank you. Thank you. You should use continental coffee. Continental? So, I put Nestle instant coffee. Hi. Somebody's back to give me hugs and kisses. Then I put the milk powder or the whole milk. Then I add water. Hi, Shona. Hi, Shona. Ah! Suji, don't leave me. Suji, mama. Suji. Let's see if she'll give me more kisses. Let's see if she'll give me more kisses. Suji, mama. Suji, mama. Oh, mama. Oh, mama. Oh, mama. Oh, mama. Suji like the halwa? Halwa? What do you mean halwa? I'm so happy that Suji decided to love me. Oh, the bread. She made some bread pudding on me the other day. I mean, she makes it almost every day, but yeah. Halwa. Oh, I know what halwa is, but I didn't know what you meant by her. But yes, she made bread pudding on me. Brett says dogs are better. Indian pudding. Halwa. Oh! Oh! Sachi. Sachi is coming. Steven says good night all. Good night, Steven. It's okay. It's okay. It's okay. It's okay. It's okay. It's okay. Ah. Sachi. Okay, we will show you Baji as well. It's okay. It's okay. It's okay. Oh. Oh. Okay. 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 তুমি থাকো তুমি এখানে বসো শোনা খুব ভালো Suji is a girl. This one is Suji or Sachi. I call her either Suji or Sachi. That's a girl. This one is a girl, the one who's been coming to visit me. Sachi's a girl. I'll show you again. This one is a girl. Baby, baby, baby. Tumi shona to. Tumi to shona. Tumi to shona. And I'll show you Baji. Now I'll show you Baji. 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 Baji Baba. This one is a boy. Baji. 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 This one is a boy. Baji Baba. Takao. Baji Baba. He's very big. Thank you, universe. Thank you, universe, for my children. Fuji Suji Baji Tu Tu Tu. Tu Tu Tu, he is very big. Oh my god. He's very big. Ore bapre. Oh my god. Baji Baba. Oh, Fuji Baba. Fuji Baba is also here. Baji. তুমি গুড নাইট বলবে সবাইকে? গুড নাইট বলবে সবাইকে? এই দেখো, এই দেখো। They understand Bengali. It's their mother tongue. Good night বলবে সোনা? Good night বলবে? What am I feeding? Oh, wet food, dry food. Oh God. Whew. Wet food, dry food, they eat everything. Oh, you were in Kolkata? I'm from Kolkata. Baji Baba. Baji Baba. Baji Baba. Clip banabi, Baji Baba? Clip banabi? Okay. Good night. Can you see the full thing? Can you see him? Tu. Baji Baba kintu mota na. Baji Baba kintu mota na. Baji Baba kintu mota na. একটু খেতে ভালোবাসে বাজি, একটু খেতে ভালোবাসে, একটু খেতে ভালোবাসে। বাজি কামড়াবে মাকে? কামড়াও। It's okay, baby. Baji wants to bite me now. It's okay, baby. It's okay. বাজি দেখো তুমি কত ক্যামেরা ফ্রেন্ডলি, দেখো কত সুন্দর লাগছে তোমায় ক্যামেরায়, কত সুন্দর, এত সুন্দর। Hi Combat Sports. Hi, here's Baji. He has attacked my hand. Ah, Baji. Okay, Baji. Okay. Sofa I wash up. Oh my god, my arms are. Today I bench pressed. So my arms are tired. I did bench press and squat and then did swimming. That gym did not make me tired. Whew. Whew. My arms are so tired now. I hope a kitty cat finds food. I want all kitties to find food and be well fed. It's okay to put yourself first. That's the lesson from cats. It's okay to put yourself first, and it's okay to take care of yourself and feed yourself and make yourself happy. Don't be a dog, be a cat. I feel bad. I want to adopt all the cats. Be a rat. Rats are pretty clever. Well, their food is about to fall. Let me see. Okay. You'll be a cat lady for real. What do you mean you will be? I am a cat lady. I'm not just a cat lady, I'm a cat mom. I'm not just a cat lady. I'm like cat lady plus plus. Okay? I'm a cat mother. I birth cats. Oh yeah, I want to adopt. I do. When I travel, do you guys understand my problems here? When I travel and I meet cats, it's very difficult. One time, oh my god, I also meet the friendliest cats in the streets. I meet them. Cats find me. The cutest cats find me, and I just cannot even. I cannot. I'm done. I can't. I'm gonna bring them all to Boston. In fact, I'm gonna go to Rome. Did you know that there is a spot in Rome for just cats? I'm gonna go there and I'm gonna help out with the cats. I'm gonna go back to the Rome. I'm gonna go back to Rome, not just for its ancient ruins, which I do. I do want to go back to Rome for the ruins and for, yes, Istanbul is another one that is very much on my list. Absolutely, absolutely Istanbul. But I want to go to Rome, not just because of the history, and I love history too. Love history, love, yeah, Katstanbul. Yeah, I love history, I love archaeology. Yeah, but also I love cats, and there's a cat situation going on there, and I need to go to Istanbul. You're a cat woman. Animal person, yeah. I like dogs too, Brett. I really like dogs too, the bigger dogs. I think I like big dogs. Like, I grew up with dogs more than cats. Like my grandparents had dogs. You should get an iguana. I'll see what Suji thinks of that. Suji's they're all very territorial, but Suji is a very good huntress. She might kill the iguana. Baji? Why are you eating Suji's food? Baji, don't do that. Don't eat her food. Suji needs to gain weight, Baji. And you need to lose a little weight. Did I tell you guys that Suji once hunted a mouse? I came back from work and there was a dead mouse in my living room, and she showed it to me, and she was so proud. She was so proud. And she killed it so well, like so cleanly, like it was like a sleeping, looked like just a sleeping baby mouse. Fresh. No, it was a mouse. It was small. It was very small. Actually, kind of good looking. It was a pretty good looking small mouse. Like the fur, everything looks fresh. A rat is bigger. Rat is like this. Rats are bigger. I've worked with rats, like, you know, like lab rat. Sometimes they have rats in the lab for like neuroscience and stuff. So I worked in a lab. Oh, she loves you? Who, Suji? Of course. I'm her mother. I'm her biological mom. Of course she loves me. Thank you, God. Thank you, universe. So, yeah, the fur was like fresh, like on. It looked like it was just sleeping. She didn't make a mess, but she killed it. She killed that mouse. Not biological. Well, don't tell her. She thinks I'm her biological mother, okay? Oh. All right, guys. She's a killer. Yeah. She's a predator, just like us. Listen, cats are not bigger predators than us. Oh, Baji's drinking water. Good job, Baji. Good job. Palace na? Khao. Baji's drinking water. That's a good thing. Good job. Eat your snack. Drank your water like a good boy. Coconut oil worked wonders. Oh, thank you. We are the biggest predators, yeah. Some cats are bigger than others. Well, yeah. So, I actually really like tigers and lions too. I wish I could have a tiger or a lion. Kind of want to raise a lion or a tiger, you know? But you could. I really want to. No. Why raccoon first? No, I want to do a lion. I want a lion. I want a lion. I want a lion. Tiger. So, I have a lot of cuteness with the thanks to the universe. Oh, all American. Yeah. Alright, guys. Thank you for chatting. Varun, are you in India? In America? California? It's getting late in the East Coast. It's getting late in the East Coast. Change their goals. Hi, Fuji. ফুজি তুমি কত সুন্দর দেখতে ছেলে, কত সুন্দর তুমি দৌড়ে এসছো। কত সুন্দর ফুজি, কত সুন্দর। এই নাও শোনো। Baji. Okay, let's see. Let's put this away. Oh, Suji Mama is in the live. Couple of dishes. Alright. I'm going to turn the lights off now. Slowly. use their water. Okay, now I'm gonna give myself a water. Alright. Let's say bye to everybody. Good night. Good night and sleep tight. Bye bye. Bye bye. Bye bye. Bye bye. Good night, sleep tight. See you next time. See you.